Hey, what's up everybody? Welcome back. So today I'm working on my English wheel again. I'm working on the upper wheel. I gotta countersink. I gotta mill out a pocket to put in my bearings. I have one on each side, so I'm gonna film the process of doing it on one side on my Bridgeport CNC mill. So let's get started. So first thing you got to do is you got to get your wheel clamped down and you got to get it indicated to where it's centered, dead center. The quill is dead center with the center of your wheel. Now I had this part machined out or milled out, and that's where they said dead center is. I don't know. I'm not 100% positive on it. By the looks of it, it doesn't look like it according to my indicators. So I've already dialed this in and zeroed it out with the indicator because this is a very time-consuming process. I made blue lines. I'll explain it to you the way I did it. So I put this thing on here and made blue lines in both my X and Y axis. Now I did that so when I bring my indicator down, I can check it at the same exact spot on each 4 spots. And I also made sure that my Z, I was coming down to the same exact point on my Z axis every single time. Like I said, I had this wheel turned down because my lathe isn't big enough to do it, to clamp it from the outside. So I had it turned down, then I made a pin that goes through here and clamps and bolts to it so I could put it in my lathe, and then I polished my backside, or polished the outside. Now, like, I don't know if I messed it up when I polished it, but I will tell you, as soon as I put the sanding disc on it, I seen a step in my machine part. I was not happy, but it is what it is. Lesson learned. Next time I'll figure out how to do it myself. That way I know that it's straight all the way across. I would have thought they would have drilled the center first, put a pin through it, bolted it, clamped it somehow that way, and then turned the whole face of it. That's the way I would have done it. If I do it again, that's the way I will do it. But moving on. So now I've got this zeroed in on all four spots. So when it goes around here, it stays on my indicator within one line. Now these lines on this indicator, I don't know if you're going to be able to see it, is 0.005. 0005. So I'm going to raise this up. So the way I've been doing this is I raise it up to go over my clamps, and I got my knee low enough to where this clears. You want to make sure that when you're spinning this thing, these are going to clear your clamps. I already hit it once. And I'm also using this tool, being very, very careful not to touch this because this is very sensitive and it will move. So we'll spin it all the way around. And I'm always going in the same direction. I'm not coming back and forth. Lightly clears it. Now I'm going to start bringing it down to my point. I'm going to start bringing it down. And now I'm going to watch my Z axis and make sure, and I'm going to go to 0.2280. That's what I was going to on my Z axis when I was doing all my measurements. little too far. Now that you can see, this is very sensitive. Like I'm barely moving it, so 2280, perfect. Now this indicator should be at 0. Look at that. Damn near dead nuts, 0. Now I can rotate this around and they will stay within 1 mark, maybe 1.5, but it'll stay in there. And I'm confident that that is probably some deviations in the outer part of the wheel, because I've raised and lowered this thing on all these spots a lot of times, and I'm getting the same exact readings on those same exact spots. So there it is. It's dialed in. My XY0 is set. Next, I'm going to remove the quill, or remove this indicator, put in my tooling, and set my Z axis, and then I will start programming the CNC to run the pocket. So first things first, I got to remove this indicator. I thought about indicating the inner hole too, but it's so rough. It's such a rough cut. Like, they didn't clean it up at all. Like, this thing will be bouncing all over the place in there, so it seems kind of pointless to me to try and indicate that. So I'm not even going to worry about it. Now I put a piece of wood in here for when I release this thing. So I got a quick release coil shaft in here. So I hold the upper lever and lock it, put this in here, and it releases. If I don't put the piece of wood in there, then the tooling falls down, falls on your part, falls on the floor, and damages it. And we don't want that. Now, I'm using a 3/4 inch end mill, flat end mill, to do this. Clean that off. Put this bad boy in here. Tap it in place. Hold the lock. Lock it. Okay. Now let's just see if this thing comes down dead center. Look at that. Their hole is pretty good, pretty close. That thing came right in there. Came right in dead center. So now I'm going to raise this back up, and we are going to set our Z axis. Now, the way I've been setting my Z axis is I've just been pulling it down until there. Now that's what I'm setting as my Z axis, my Z0. As soon as it stops, going to datum, Z0, move back to Y0, and use. Now all my axes are zeroed out. I'm at XY0. Okay. Now I'm gonna put one more clamp on this just for security reasons, and then I'll start programming. Okay, so this DRO or this CNC is really cool. I got all these things over here that I can use to design all kinds of different things. I can also program in a CAM program and transport the files to here, and it'll do it too. I don't know how to do that. I don't have the software to do that yet, so I'm just manually programming. So the first thing I'm going to do is go tool. Oh, no. Cancel. I'm going to go program, tool, my tool diameter. We're going to oversize the tool. This is a 3/4 inch tool, so I'm going to oversize it so I can sneak up on my hole size. Overall diameter of my bearing is 1.854. So I'm going to put in here when I go to the circle, I'm going to have to punch in the radius of 0.927. So I'm going to oversize my tooling and then put my radius at what it needs to be, and the program is gonna think the tool is bigger than what it is, so it's gonna undercut my diameter. That way I don't overcut it. I can sneak up on my cut and get a final pass and get a final cut and make it a nice finished cut. So I wrote down all my stuff that I did because I already did the bottom. So wrote everything down, and now I'm doing it again. So diameter, we're going to start out with 0.7750. Length, leave that blank. Tool type. Flat end mill, enter. Spindle off, speed. X, tool position, X0, enter. Y0, enter. Z0, enter. Use. Now my tool is set. Now I go into circle, and I want to do a pocket. I can do a pocket, a frame, a ring, or a helix. I want to do a pocket. So I'm starting at 0. At my XY is going to start at 0. My Z begin is going to start at 0. And my end is going to start, we're going to end it at negative 0.550. And then I will, again, when I go to sneak up on it, I will go down to a full depth of 0.50. So number of passes, we're going to do 10 passes at 5 inches a minute. Radius, like I said, my radius is 0.927. We're going to cut in a counterclockwise direction. And then that's it. Hit use. And there's my circle. Now we'll do run options. And we'll do a graphics only. And we'll hit go. Now it's going to set my tool. Yes. And it's going to come around and it's going to follow that circle. Now these are in increments of an inch. Like that's a half inch, that's an inch. So you can see that it's less than 2 inches, which is good. And that's going to do that all the way around. So that's that. So we're going to stop that. I don't need to do that no more. Now we're ready to go. So I'm going to plug it in, turn it on, lube it up, and then we'll get going. All right, it's plugged in, ready to go. We're going to turn it on up here. I'm gonna hit go. I got my Z axis up. As you can see, it's up above the part, and it's gonna do it its own way. Go back up to the set tool, go. It's gonna say no current tool, but on the current step, it's gonna set the tool. Okay, the tool is set. 0.7750 in mill. Press go. And there we have it. All right, it just finished its first pass. Looks really, really good. And look, it is undersized, meaning I did not overcut it. So the bearing, now I can change my tool diameter and my tool diameter alone and start sneaking up on my outer size. So last time, I went down 1,000. No, hundreds. I went down 100th. So I'm gonna go back over here. I'm gonna go up to my tool. I'm gonna enter the tool, and now I'm gonna change this to 0.7650. And that's all I'm changing, not changing anything else. Leaving that the same, use that. Use. Okay. Now, I will lube my tool again. And then we will start it over. And we'll do another 10 passes, slowly sneaking up on our diameter for our hole, and we'll do it until our bearing fits in there nice and snug. Now this stuff I'm using is called Anchor Lube. It's an all-purpose metalworking compound. The reason why I like it is because it sticks. It stays there. It doesn't fly all over the place. All right, turn the machine on, and we'll start it again. Now we're only going to cut a little bit away. But you see up here, my tool has changed from 0.7750 to 0.7650. So we're only going to take away a little bit. We're just going to sneak up on that hole. All right, it's gonna do 9 more passes and then it'll stop and then I'll come back. Okay, just finished the second pass. So check it again. Still not big enough, which is exactly what I was wanting for. I was hoping that it was not gonna be big. Well, I knew it wasn't gonna be big enough because I've done this before. So now I'm gonna start going down 50 thousandths or 5 thousandths. Yeah. I'm gonna decrease my tool diameter again and again and again until the bearing fits in there. I think I have to do it probably 3 more tries, maybe even 4 more passes. But so you know the process. I just go up to my tool, change my tool diameter. Now we're gonna go 0.760. Yep, because last time I went 0.7650. Now I'm gonna go 0.760, use, and then I'm gonna start the whole process over. So you get what I'm doing. I hope you get what I'm doing. I'm sneaking up on my outer diameter by changing my tool size. So my radius, not diameter, my radius is 0.927. The CNC calculates how much it needs to move based off the tool diameter. So I started out with an oversized tool. Now I'm slowly creeping down to where it gets the right size diameter hole, and I'm sneaking up on it so I don't overcut and ruin the part. My first pass, I tried doing it full size, and I don't know, I must have punched a number wrong, but I was oversized by 20 thousandths. So I had to go buy some bigger bearings, and now I'm oversizing the holes to those bearings now. So you get what I'm doing? No reason to keep going. So I will get this all programmed up, get it all turned down, and then show you when I got the bearing fitting in nice. Okay, I finally got it. I took my time, I snuck up on it. My final number on my tooling was 0.7545. Now this bearing, like, I've been playing with it, like I can get it in there, but I don't want to get it in there yet. I don't want to put it in there yet because I need to pull it off, and I need to deburr it and everything like that, and I want to get it cleaned up before I pop this bad boy in there. So that's what I'm gonna do. I'm gonna deburr this, and then that thing's gonna be going in there and it'll be ready to go. But that's how I can do this on my CNC. Program it up and slowly make it bigger until the bearing fits, making sure not to oversize it, because as of right now this is a $500 piece of metal. By the time I ordered it and got it, and then the machine work to be done on it to get it to where it's going, plus then my time, like, yeah, this is a $500 wheel, so don't want to be wasting that. So make sure that you sneak up on your diameters. All right, that's going to be it for this one. Again, thanks for watching. Don't forget to hit the like, subscribe, notifications button. And then this will be the next part of the English wheel. I'll get this finished up, get it up on the wheel, and then I'll start working on the lower anvil part. Catch you on the next one.